Two Trees is considering a capital loan so that they can expand production by buying some capital equipment. But they want to see a whole bunch of options for how much is this loan going to cost them, depending upon how long it takes them to pay back, or maybe how much money they borrow. If you watched the movie on GoalSeek, you saw that we were able to substitute one input, maybe just the interest rate, or maybe just the amount that they're borrowing. Well, using the data table feature, we can substitute one or possibly two entire range of inputs. In this workbook, you want to be in the single variable worksheet. And let's take a look at what we're doing here. We have about $100,000 that we're going to borrow, and the company thinks that the interest rate will be about 6% per year and is thinking of paying it off over a period of 10 years. And we'll use the payment function for that. And if you click on the syntax tab, you can see the syntax of the payment function. So we see equals PMT. What's the interest rate to be charged? How long will it take to pay back? And what's the present value? Which basically means how much is that check going to be the first day that we get it from the bank? What is that loan worth? So let's go to the first tab here, single variable. And what we'll do is we'll substitute only how many years will it take to pay off. So click here in cell D11 and we'll use the payment function. So we'll say equals PMT, open up the parenthesis. What's the rate? Well, here it is, 6%. Keep in mind, that's 6% per year. We're going to pay this loan back every month, so we have to take that 6% per year and divide it by 12 to get the monthly interest rate. So type a comma and we'll put in the next argument. The next argument is how many periods? Well, it's 10 years, not 10 periods. So click that 10 years and we need to multiply by 12. So 10 years, the number of periods will really be 120 months. Type a comma. What's the present value? Well, the day we get the check from the bank, the present value is the full $100,000. And press Control Enter, so we enter and stay on that cell. And we can see it's a negative number because it's a cash outflow. We can see that every month we will write a check of about $1,100 to the bank to pay this off. Well, maybe Two Trees can't afford all that, or maybe they're flush and they can afford to pay back some more. So here we can vary how many years it'll take to pay back, from paying it back over 1 year through paying it back over 30 years. So let's select all the cells inside this box. And keep in mind, when you do this, this is kind of specific. You have to put this function in this cell, and you have to put these numbers here kind of in that adjacent column. So now go up to the Data tab, click on What If Analysis, and choose Data Table. Now, this Data Table dialog box is not the most intuitive thing in the world. It's asking row input cell, column input cell. What is that? Well, there is no row input cell, so let's leave that for now. Click down here in column input cell. Well, what is the column? Well, down here in column C, these are the number of years that we're going to pay back. What is that substituting? Well, that's substituting for this number where our payment function is getting that figure. So click on that 10. So that cell D7 is what's going to be substituted for when we go down this column, and then our payments will appear in this blank column. So click OK, deselect, and now we could see that $100,000 at 6% interest, if we pay it back over 1 year, every month we'll write a check for about $8,600. $100,000, 6% interest rate. If it takes us 30 years, every month we'll write a check for about $600. And if you want this formatted really to look like dollars, we can just select those figures, go to the Home tab, and click this dollar, and now it looks like dollars. And negative, right, because the money is coming from their pocket and going out. Well, that's great, but what if we want to vary not just the number of years, maybe we have another input we want to vary. So let's go here to the dual variable table. Now here we can vary not just how many years it'll take, but how much money we can pay that back. And I'm assuming that the company doesn't have a lot of control over the interest rate, but it probably can control how long it'll take to pay back and certainly how much to borrow. So let's put in the payment function again. And again, it has to be specifically in this cell here, A11. So again, we'll put in equals PMT, open the parenthesis. There's the rate divided by 12, type in a comma. We want the number of periods. There's 10 years times 12, just like in the last sheet. Type in a comma, and it's the same present value, that $100,000, and press Control Enter. So there's the payment function. Now, again, let's select all of the cells in this box. So starting from A11, down and across to select all the cells in that box. So let's go back to the Data tab, back to What If Analysis, Data Table, move this out of the way. Now we're going to use both of these fields. The row input cell, well, what's the row? Well, we have in row 11, we are substituting for that present value. So click that present value. Go in here to the column input cell. Well, what's the column in the table? The column in the table is substituting for the number of years. So click that number of years, and that's it. Click OK. And now we can see, let's just select that and format it as dollars before we talk about it. And now we can see, for example, if we borrow $95,000 and take 20 years to pay it back at 6%, every month we'll write a check for about $681. Or if we borrow $110,000 at 6% interest, pay it back over 5 years, it'll cost us a little over $2,100. Now, there's no rule that says you have to use these specific variables and this specific payment function for data tables. For example, if interest rates are volatile, you might try higher and lower interest rate amounts. Or maybe you need to see cosines and tangents of different angles. So you can think of data tables as sort of a kicked up type of autofill.